Assalamu alaikum. Today we are going to start exercise 1.3 for chapter matrices. We've already done the part 1 for this exercise, and today we are going to do the part 2. So the part 2 includes question number 9 to question number 14. Before entering to the exercise, we need to understand a few properties. So there are two properties used in this part of the exercise. The first is commutative property. So commutative property actually means if we just talk about real numbers, so if we add two numbers, a plus b would be equal to b plus a. It's a quite simple property. So if we just assume real numbers for it, 2 plus 3 equals 3 plus 2, so this equals 5, and 3 plus 2 also equals 5. So this property tells us about this. This property is also applicable over matrices, and we are going to do it practically in the exercise. So let's move on to the next property, which is associative property of addition. So that is property is a plus b plus c equals a plus b plus c. So if we suppose numbers for it, 1 plus 2 plus 3 equals 1 plus 2 plus 3. So 1 plus 5, and this is 3 plus 3, so 6 equals 6. So this property is also quite simple and also applicable over matrices. I hope you understood it, and we are gonna just move on to the exercise now. So question number 9, the first question says, let A equals A and B, A, B and C be these matrices. If C equals 2 and D equals -4, then verify this kind of an equation. So we're given the values of small c and small case d, and we are also given the values of these three matrices. Here, if you just notice, there's another property which I missed here. So this is called distributive property. As the name suggests, okay, so let's take this example. A plus b into c equals AC plus BC. So this would multiply with these both, and what it would be equal to these both AC and BC. So 1, let's take values, 2 plus 3 equals 1 into 2 plus 1 into 3. So 1 into 2 is 2 plus 3 equals 2 plus 3, and 5 equals 5. So this is another property called the distributive property, which is also applicable on matrices. So question number 9 is all about distributive properties. So let's start the answer for this solution. So solution, the first is c plus d. So the value of c is 2, and then plus, and then d is -4 with an A matrix. So A matrix is 2, -3, 4, and 5. So, and okay, so first we're gonna find the left hand side. This is the left hand side, and which equals to let's just write it as it is, CA plus DA. So let's solve the left hand side first. So 2 minus 3, 2 minus 4 is -2. Then the matrix 2 minus 3, 4, and 5 equals this same. So just simply multiply it with the values inside. So 2 into 2 is 4, so minus 4, 2 3 is 6, and 8, and then minus 10, and this is also minus. So here we got the value of left hand side. Now we're going to prove the right hand side. So right hand side, okay, so equals, just write this, CA plus DA. Okay, so minus 4, 6, minus 8, minus 10 equals C. The value of C is, okay, I don't need brackets here. So value of C is 2, and then the matrix A, which is matrix A is 2, minus 3, 4, and 5. 2, minus 3, 4, and 5. And then plus, it's D. So D is minus 4 into the matrix A. 2, minus 3, 4, and 5. So this will come as it is. 2 into 2 is 4, minus 6, 8, and then 5, 10. So, and plus, this would become minus here. So minus 4 into 2, minus 3, 4, and 5. Okay, so simply multiply the 4 here. So 4 minus 6, 8, 10, and multiply the 4. So minus, it will become minus 8. So minus 8, then minus 8, and then 12 with minus 16, minus 20. Okay, we're running out of space here. So 4. Now we're gonna add these both matrices. So 4 plus minus is minus 8, minus 6, minus 6 plus 12, 8 minus 16, 10 minus 20. So our answer is minus 4, 6, minus 8, and minus 10. And here the left hand side, let me write it here. So minus 4, 6, minus 8, and 10. So these both sorry, here's minus 10. So these both matrices are equals, which means distributive property here is applicable, and left hand side equals right hand side. So the next part, we're going to start the next part, which is this. So here we know, so okay, solution. So we know this value of C is 2. So 2 into the matrix A. So matrix A is 2 minus 3, 4, 5, matrix A, then plus matrix B, which is 2, 5, minus 1, and 3. So, okay, and we're gonna write the right hand side as it is. So plus CB. Okay, now we're gonna multiply this first we add these both and then multiply the 2 with it. That would be easier. So 2 plus 2 minus 3 plus 5, 4 minus 1, and 5 plus 3. 2 4 2 4 2 8 4, sorry, not 8, 3. Okay, so So for 3 and 8 here. Okay, so now we're gonna multiply 2 with it. So 2 is 8, 4, 6, 16. So we got the left hand side here. So LHS, left hand side. Right hand side is CA plus CB. Now we're gonna put the values in the right hand side. So right hand side is C is 2. So 2 into A is 2 minus 3, 2 minus 3, 4, 5, and then again C 2. Then B is 2, 5, minus 1, and 3. We're gonna solve further. So 2 multiply 2, 4 minus 6, 8, 10, plus 4, 10, minus 2, and 6. So adding these both, 4 plus 4 minus 6 plus 10, 8 minus 2, 10 plus 6 will equal 8, 8, 4, 6, and then 16. So this is the right hand side, and the left hand side is 8, 4, 6, 16. So we got the left hand side equals right hand side. So it's proved, right hand side. Okay, moving on to the part 3. Part 3 is CD into A equals C into DA. This is also that property, and simply we're going to put the values here. So let's do the left hand side first. Left hand side is C is 2, then into minus 4 is D, and the matrix A. So that's 2, minus 3, 4, 4, and 5. Okay, so 2 into minus 4 is minus 8. So minus 8, and then the matrix, simply multiply it with all the elements. So minus 16, 24, minus 32, minus 40. Sorry, this is minus 40. This is the left hand side. Moving on to the right hand side. So right hand side is C into DA. C into DA, which would equal C is 2, and then D is minus 4 into A. So A is 2, minus 3, 4, and 5. So first multiply minus 4 with all the elements. So it will become, or maybe just multiply 2 and 4. That would be easier. So 8 into 2, minus 3, 4, and 5. Multiplying 8 minus 16, 24, minus 30, 32, and minus 40. So left hand side equals right hand side, minus 40. So this is also proved, right hand side. Okay, moving on to question number 10. Question number 10 is quite simple, so just simple multiplication and addition. So compute the following when these three matrices A, B, C are given. So let's put the values simply. A is, so solution is A minus 1 2 3 4 2 0 minus 3 2 and 5. So plus 2 is multiplied with B. So B is 3 minus 1 2 minus 5 3 4 minus 3 minus 4 and 0. Firstly we're gonna multiply this 2 with all the elements of B. So same it as it is. Then multiply 2, so plus it will become 6 minus 2, so minus 2 4 minus 10 6 8 minus 6 minus 8 and 0. So this is minus 6 minus 8. Okay, we're gonna add these both. So minus 1 plus 6, then 2 minus 2, 2 minus 2 3 plus 4 4, 4, this is 10, so this is 10, 4 minus 10, 2 plus 6, 0 plus 8 minus 3, minus 3 plus this is minus 6, 2 minus 8, 5 minus plus 0, and the answer is 5. So 5 0 7 minus 6 8 8 8 minus 9 minus 6 and then 5. So this is the answer for part 1 of question number 10. Moving on to part 2. Part 2 is 3a minus 4b. So 3 into matrix A. Matrix A is minus 1 2 3 4 0 2 0 minus 3 2 and 5. Minus 4 into matrix B, which is 3 minus 1 minus 1, okay, minus 1 and 2 minus 5 0. So this is the B matrix, multiplying 3 and 4 with A and B respectively. So 3, just multiply. So it will become minus 3 6 9 6 9 12 6 0 minus 9 6 and 15. Okay, so minus 4 will multiply with the next matrix. So minus 4 with the next matrix, minus and then 12 minus 4 8 minus 20 12 16 minus 12 minus 16 and 0. Simply subtracting these both. So subtracting, so minus 3 minus 12, 6 minus 12, minus 4, so plus 4, 6 plus 4, then 9 minus 8, 12 minus 20, so plus 20, so plus 26, 6 minus 12, and 6 minus 16, so 6 minus 16, I mean, sorry, this is 0, this is 0 here, so 0 minus 16, minus 9 plus 12, 6 plus 16, 15 minus 0. At last we get the answer, minus 15, 10, 1, 32, minus 6, minus 16, and 3, 22, 15. So this is our answer. Moving on to part 3. Part 3 is A plus B minus C. So this is just no real numbers in it, like these. So A matrix is minus, okay, this is gonna be a bit messy, minus 1, 2, 3, 4, 2, 0, and minus 3, 2, oh, minus 3, getting a bit messier. So we're gonna write simple matrices here. A matrix is here is minus 1, so minus 1, 2, 3, 4, 2, 0, minus 3, 2, 5, then plus, and this is a big oh my god. So a big bracket, parenthesis, plus B is 3 minus 1, 2 minus 5, 3, 4, minus 3, minus 4, and 0, and then just add this, subtract C outside the bracket. So subtracting C, okay, so minus, and C is 2 minus 3, 6, 0, 4 minus 1, 5 minus 5. Okay, just add these both, these, because these are in the parentheses. So adding these both will give us minus 1 plus 3, 2 minus 1, 3 plus 2, 4 minus 5, 2 plus 3, then 0 plus 4, minus 3 plus minus here, minus 5, so minus 3, this is not, I think this is not 5, minus 3, this is 3, so 3. So 3, minus 3, 2 plus minus 4, 5 plus 0, and then just subtract this. We won't write it here. This will give us is the 2. So 2, 1, 5, minus 1, 5, 4, minus 6, minus 2, and 5. Subtracted is 2, minus 3, 6, 0, 4, minus 1, minus 5, 1, 3, and simply subtract it, and we get the answer as this matrix is, which is 0, because 2 minus 2 is 0, 4 minus 1 minus 1, 1, 5 minus 1 minus 3, and 2. So this is our answer for part 3. Moving on to part 4, a plus b plus c. This is the similar to the one we did earlier. So these are two parts of a commutative property. This would be equal to the upper one. I would leave this one for you to practice, because the answer of this would be equal to this answer. So try to get this answer from your after you solve it, and I'd rather start question number 11, which is prove that in one of the following matrices commutative property of addition holds. So let's see in which of those commutative property of addition holds. So we know that commutative property is a plus b equals c plus a plus b equals b plus a. So a plus b, so it's the left hand side first. So left hand side first, which is equal to a plus b. So a is 7, 1, 2, 4 plus 1, 1, 2, 2. This is the left hand side. Adding this 7 plus 1, 1 plus 1, which would give us 8, 2, 4, and 6. So this is the left hand side. Now the right hand side, which is so that is b plus a. So b plus a. So b is 1, 1, 2, 2, and plus 7, 1, 2, 4. Adding these both, so that this is 8, 2, 4, 6 equals 1 plus 7 is 8, 1 plus 1 is 2, similarly 2 plus 2 is 4, and 2 plus 4 is 6. So left hand side equals right hand side. So in part 1, commutative property of addition holds. Let's check out this for part C. So part C, let me write the part C here. Part C is C equals minus 3, 4, minus 5, 2, 3, 1, and then D is minus 3, minus 4, 5, 4, 5, 1, 2, and 3. So this is the question, and a plus b, so c plus d here equals d plus c. So first left hand side, and that is c plus d. So minus 3, 4, minus 5, then plus d, so just add these both. So minus 3, then 4 minus 4, minus 5 plus 5, 2 plus 1, 3 plus 2, and 1 plus 3, which will give us minus 3 minus 6, 0, 0, 3, 5, 4. Now the right hand side is d plus c. So d plus c. D is minus 3, minus 4, 5, 1, 2, 3, and plus c is minus 3, 4, minus 5, 2, 3, 1. Okay, so adding these both, minus 3 minus 3, minus 4 plus 4, 5 minus 5, 1 plus 2, and the 2 plus 3, and 3 plus 1. So the right hand side is minus 6, 0, 0, 3, 6, 5, 5, and 4. So right hand side equals left hand side. Moving on to the question number 12, which is verify a plus. Okay, this is the simple associative property which I taught you in the start. We're going to prove it here for these three matrices. So first, left hand side, of course. So left hand side, a is 2 minus 3 4 1, and then these plus, and close these b plus c in parentheses. So b is 5 minus 2 3 6, similarly plus c, so plus c, in parentheses close. First solve the two matrices here. So add these both. So 5 plus 1, then minus 2 plus 7, 3 minus 6, and 6 minus 3. 2 minus 3, 4, and 1, plus 6, 7, this is 5, minus 3 and 3. Now add these both. We'd get 2 plus 6 minus 3 plus 5, 4 minus 3, and 1 plus 3. Which will form 8, 2, 1, and 4. So this is the left hand side. Now we'll solve the right hand side. A plus b plus c. So a, we're gonna write a separately. Oh, maybe sorry, the a in brackets, a and b in brackets. So this is the right hand side. So a, okay, I don't need to write this. A is 2 minus 3 4 1, plus b then plus c. So c is outside. 1 7 minus 6 minus 3. Solving this further, so first solve these both here. Let me just go a bit direct. So 2 plus 5 is 7, then minus 5. 4 plus 3 is 8. I'm sorry, 7. So that's 7, and 1 plus 6 is 7. Plus 1 7 minus 6 minus 3. Adding these both. So 7 plus 1 minus 5 plus 7, 7 minus 6, and 7 minus 3. So 7 plus 1 is 8. Okay, so 8, and that is 2, 1, this is minus here, so 7 minus 3 is 4. So if you just tally these both, these are equal, and we've proven that right hand side equals left hand side. So part 2, we have part 2 here. So I would leave this work on you to do it. It's the same as this part. So although I would have done it, but I want you to practice, so you need to practice a bit in these things, because maths is all about practice. Yes. So okay, let's just leave this maybe, or if you want me to do it, so I'll just give you the answer for this one. It is a plus 3, then b plus 3, c plus 2, 4, 6, 7 equals a plus 3, b plus 3, b plus 3, c plus 2, 4, 6, 7. So left hand side equals right hand side, and this would be the answer. Be sure to practice this question. Moving on to question number 13. It is find the additive inverses of the following matrices. So additive inverse means just then the matrix which we have to add with this matrix to get a null matrix. So we know that null matrix is all the elements of null matrix are zeros. So a number which has to be added with this to which equals then it makes this matrix equals a null matrix. So additive inverses, finding additive inverses is easy. Just add the same number with the opposite signs. So 3, okay, copy this down. This is the same matrix, and subtract another matrix with different signs. So that add. So the other would be -3, -4, -6, and -2. And if you add these, so 3 minus 3, 4 minus 3, 6 minus 6, and 2 minus 2 equals a null matrix. So this is the additive inverse of this A matrix. Next question is find the additive inverse of part B. So part B is we just need to write a matrix with opposite signs. Copy this down. Down, B, L, M, and N. So add a matrix with opposite signs. Minus A, minus B, C, minus A, B, minus L, minus M, minus N. And B equals A minus A plus A, B minus B, minus C plus C, A minus A, then minus B plus B, L minus L, M minus M, N minus N. So it's also a null matrix here, 0, 0, 0, and all zeros. So null matrix is the answer. So next is question number 14. Show that the following matrices are additive inverses of each other. So additive inverses, part A is, we know additive inverse. So part A is 1 minus 2 and 3 and B is minus 1, 2 and 3. So we have to show that these both are additive inverses of each other. We know that the answer would be a null matrix. So if the answer is a null matrix, then these both are additive inverses. If not, then these both won't be additive inverses. So adding these both, A plus B will give us 1 okay, let me just write it separately first and then together, then plus minus 1, 2 minus 3. So 1 minus 1 minus 2 plus 2, then 3 minus 3 equals a null matrix. So A and B are additive inverses of each other. Part 2 is with square matrices. So A, let's just simply add minus B. Oh, sorry. Okay, so A, then minus B, minus C and D, plus minus A, B, C, minus D. Add these both and you'd get a null matrix. So A minus B plus B minus C plus C, D minus D is 0, 0, 0 and 0. So you got a null matrix, which means C and D are additive inverses of each other. Part 3, which is the last question of this exercise, it's a 3 by 3 matrix. So 1 minus 2 minus 4, 2. So add these. 1 minus 1 minus 2 plus 2 minus 4 plus 4, then 2 minus 2, 1 minus 1, 3 minus 3 minus 3 plus 3, 4 minus 4 minus 2 plus 2. So adding this, we'd get a null matrix. So 0, 0, 0, zeros, so null matrix. So this means E and F are also additive inverses of each other. With this last question, we reach to an end of part 3. Be sure to watch all the videos above, which if you didn't watch them, and be sure to subscribe, and thanks for watching.